This is the Sea Vixen, a groundbreaking British two-seat fighter, famed for being the first of its kind to break the sound barrier. Initially known as the DH.110, the Sea Vixen captivated Navy servicemen with its distinctive twin-boom tail and innovative cockpit design. Excelling beyond expectations in its early days, it became a pivotal player during the peak years of the Fleet Air Arm and a cornerstone of the Navy's aircraft carrier force. Notably, it played a key role in the significant operation that thwarted Iraq's plans to invade Kuwait. However, the Sea Vixen's journey was shadowed by tragedy and intrigue, adding a layer of mystique to its history and making it a subject of great interest and speculation. In 1946, a pivotal meeting between de Havilland and the British Admiralty set the stage for an aviation breakthrough. A jet-powered fighter adept in all weathers and equipped with radar. Key requirements emerged: a two-member crew, twin engines for overwater safety, swept wings, and moderate wing loading for agility and efficient takeoffs and landings. De Havilland's response was the DH.110, a twin-engine all-weather fighter with a lineage from the Vampire and Venom, boasting an all-metal build, 45-degree swept wings, and formidable 30mm Aden cannons. Powered by Rolls-Royce Avon turbojet engines, the DH.110 became the first British two-seat combat aircraft to break the sound barrier. 1947 saw the British Air Ministry ignite a revolution for night fighters, prompting both the Fleet Air Arm and the Royal Air Force to prepare for nocturnal dominance. The DH.110, proposed for both branches and initially equipped with Metrovic F9 engines, led to orders for multiple prototypes, each tailored to specific combat roles. By 1949, the DH.110's versatility was clear, catering to long-range, night, and strike missions. However, a turn of events saw the Royal Navy opting for the more cost-effective and quickly deployable Sea Venom. Despite this setback and a reduced order from the RAF, de Havilland persevered with the DH.110, undeterred in its vision and commitment. The de Havilland Sea Vixen, a jet fleet defence fighter, was outfitted with advanced radar and air-to-air missiles as its primary weapons. Upon its introduction, it became the first British plane to exclusively use missiles, rockets and bombs, marking it as the first Fleet Air Arm fighter without any guns. The Sea Vixen FAW-1 model carried 4 de Havilland Firestreak air-to-air missiles, and the FAW-2 variant was additionally capable of deploying the more advanced Red Top missile. The original DH.110 version proposed to the RAF had 4 cannons, but this was quickly updated to an all-missile arsenal. The Red Top missile's guidance system was linked to the AI-18 radar, controlled by the observer, to track targets. Besides its primary role in fleet defence, the Sea Vixen was also utilised for ground attacks. For this purpose, it could be equipped with 2 microcell unguided 2-inch rocket packs, bullpup air-to-ground missiles, and either 4 500-pound or 2 1,000-pound bombs. Additionally, the Sea Vixen was fitted with a refuelling probe, allowing it to be refueled mid-air by tanker aircraft, thus extending its operational range. It was also capable of acting as a tanker itself, refueling other aircraft. In extreme operational emergencies, the Sea Vixen was authorised to carry the Red Beard freefall nuclear bomb. The Sea Vixen was equipped with 2 Rolls-Royce Avon 208 turbojet engines, enabling it to achieve a top speed of 690 miles per hour, 1,110 kilometers per hour, and a range of up to 600 miles, 970 kilometers. This aircraft featured a distinctive twin-boom tail design, similar to that of its predecessors, the de Havilland Sea Vampire and Sea Venom fighters. The internal space of the tail boom was utilised for storing both fuel and avionics. In the enhanced Sea Vixen FAW-2 model, this space was significantly expanded. The twin-boom tail design contributed to reducing the aircraft's overall length and height, which in turn minimised the space needed for storage and headroom on aircraft carriers. Additionally, this design offered advantages such as reduced asymmetry during single-engine operation, shorter jet pipes, and improved maintenance accessibility. The fuselage of the aircraft is segmented into several parts, with the central and stub wing assembly section being the most significant. The front part of the fuselage, which includes the pressurized cabin, the air brake beneath the pressure flooring, and the radar compartment with its hinged radome, is attached to the front spar via 4 points. Behind the front spar and above the wing, there are various electrical compartments that can be accessed through hatches. The engines are located in the main fuselage, behind the main box, and can be serviced by removing panels on the upper surface of the fuselage. The aircraft's skin includes sections that were chemically milled, as well as others that were machine milled. Additionally, the aircraft features a powered folding wing, which utilizes a pair of wing fold joints incorporating a total of 6 main attachment points. The Sea Vixen was manned by a 2-person crew, consisting of a pilot and a radar operator. The pilot's cockpit was situated on the left side of the fuselage, while the radar operator was seated entirely within the fuselage on the right side, entering through a flush-fitting top hatch, informally known as the coal hold. The radar operator's station, which was positioned lower in the fuselage and darkened, enhanced the effectiveness of radar screen visibility. Both crew members were equipped with automated, height-adjustable Martin Baker Mark IV ejector seats, designed to operate in various situations, including when the aircraft was submerged underwater. Additionally, each crew member had a central service connector that provided connections for ventilated G-suits and controlled humidity and temperature settings, ensuring crew comfort. The Sea Vixen's flight controls were quite intricate, featuring fully powered tailplane, ailerons, and rudder. These controls were designed to remain operational even without electrical power, such as during a double engine failure. The actuation of these powered flight control surfaces was facilitated by 2 independent hydraulic systems, with control movements variably geared at different speeds. The aircraft also utilized a complex 3-section flap system, which was partly a result of the wing's unique geometry. In terms of navigation and communication, the Sea Vixen was equipped with ground and air position indicators, a reference gyro, an autopilot system capable of maintaining altitude and speed, as well as providing yaw and pitch damping, a tactical air navigation system, and an ultra-high-frequency radio system. On September 26, 1951, the first prototype of the DH.110 was ready and made its inaugural flight from Hatfield Aerodrome, piloted by John Cunningham. Early test flights revealed that the aircraft's performance was surpassing expectations, and by the next year, it was routinely breaking the sound barrier. However, in 1952, a tragic incident occurred during the Farnborough Airshow. During a low-level sound barrier breaking display, the aircraft fell apart, with debris fatally striking 31 people, including spectators and the 2 crew members, test pilot John Derry and flight test observer Tony Richards. The accident was later attributed to a design flaw in the wing's leading edge section ahead of the main spar. This design had worked for the Vampire and Venom, but couldn't withstand the higher stress from the DH-110's maneuvers at 650 miles per hour. The leading edge skin, lacking sufficient reinforcement, buckled, leading to the loss of the swept-back wing's outer portions. The resulting shift in the aircraft's center of pressure caused a catastrophic breakup, with one engine crashing into a spectator-packed area, causing most fatalities. 60 others were injured by cockpit debris near the main viewing area. This disaster led to major changes in UK airshow safety regulations. Following the catastrophic loss of the first prototype, de Havilland rolled out several design modifications on the surviving second prototype. These modifications included an all-moving tailplane and cambered leading edge extensions. However, the revamped prototype didn't resume flight tests until July 1954. Due to these changes, the aircraft's speed capabilities were impacted, limiting it to Mach 0.95 in a steep dive, with control issues persisting until it descended below 10,000 feet. Around the same time, the Royal Air Force withdrew its interest in the DH-110, opting for the Gloucester Javelin instead. However, the fleet's air arm saw potential in the aircraft, considering it a suitable replacement for its temporary fleet of Sea Venoms. Consequently, in February 1955, a significant order for 110 navalized versions of the aircraft, now christened the Sea Vixen, was placed. De Havilland not only adapted the Sea Vixen for Royal Navy carrier operations, but also incorporated significant changes during its redesign in the 1950s. This period saw substantial advancements in various subsystems like weaponry, fire control systems, radar, and cockpit instrumentation. The concept of an aircraft as an integrated weapon system, where radar and other sensors are closely linked with navigation and weapons, was emerging. De Havilland incorporated this innovative approach in the Sea Vixen's design, making it the first British fighter to be designed this way. In June 1955, the naval-ready prototype XF-828, sporting key modifications like altered wing edges, reinforced wings, and a tailhook for carrier landings, made its maiden flights from de Havilland's Christchurch airfield. By 1956, it had impressively landed on HMS Ark Royal. The ensuing production Sea Vixens, starting in March 1957, boasted advanced features like a folding wing system and enhanced landing gear, culminating in the first squadron's formation by July 1959. These fighters, initially crafted in Christchurch, saw their production later shift to Harden, marking a new chapter in their distinguished service. De Havilland didn't stop at the FAW-1 model. They advanced to create an enhanced version, the Sea Vixen FAW-2. This model was an upgrade from the FAW-1, equipped with Firestreak missiles, red-top air-to-air missiles, 4 SNEB rocket pods, and the AGM-12 bullpup air-to-ground missile. The FAW-2 featured an extended tail boom for extra fuel tanks, and included improved escape systems and additional space for electronic countermeasures. However, this aerodynamic redesign meant it could no longer carry the 1,000-pound bomb. Visually, the FAW-1 and FAW-2 differed in the tail booms. The FAW-2's booms extended over the wing leading edges. The Sea Vixen FAW-2 debuted its maiden flight in 1962 and joined frontline squadrons by 1964. In total, 29 FAW-2s were built from scratch, and 67 FAW-1s were upgraded to the FAW-2 standard. By 1966, the FAW-1s were being phased out, and in 1972, the FAW-2s concluded their service. The FAW-2 could be armed with up to 4 Hawker Siddeley red-top infrared homing missiles, capable of engaging head-on targets. These missiles could detect the heat from fast-approaching supersonic targets, like the Tupolev Tu-22 blinder bomber. The red top was integrated with the AI-18R radar. From 1969, the FAW-2s was tested over the Irish Sea, practicing intercepts against the supersonic Concorde SST. Originally, the Admiralty planned to replace the Sea Vixen with the McDonnell Douglas Phantom FG-1. Both HMS Ark Royal and Eagle were intended to be refitted for these new fighters. However, due to defence cuts and the decommissioning of HMS Eagle, only HMS Ark Royal was modified for the Phantom FG-1. A few Sea Vixens later served as drones, designated as Sea Vixen D3. Only 4 were converted to this standard, and although 3 more were sent to Farnborough for conversion, they were never modified. The last airworthy Sea Vixen, XP-924, was a D3 conversion. Other Sea Vixens were used as target tugs, known as the Sea Vixen TT2. The Sea Vixen's journey from its inception as the DH.110 to its evolution into a formidable fighter in the British fleet encapsulates a blend of innovation, triumph, and adversity. Despite challenges, including a redesign following a tragic airshow accident, it proved versatile in roles ranging from fighter to naval strike aircraft. Beyond active service, it transitioned into specialised roles like drones and target tugs, cementing its legacy as a symbol of technological advancement and adaptability in military aviation. If you enjoyed this content, don't forget to hit the like button, subscribe for more, and ring that notification bell to stay updated on our latest posts. Thank you for your support.